Hurricane Harvey approached Houston, Texas several days ago, bringing torrential rains, high winds, and flooding with her. This catastrophe has caused countless losses, making us believe the importance of improving the prediction of hurricane intensities. Some study pointed out that aerosol may affect the intensity of hurricane. By incorporating this effect in models, scientists may improve the prediction of hurricane intensities. So today let's talk about these two questions. How do hurricanes form? How could aerosol affect the intensity of hurricane? The formation of hurricanes needs several conditions: light winds, high humidity, warm surface water, and surface low pressure. The energy for a hurricane comes from the direct transfer of the heat from the warm water into the atmosphere and from the transfer of latent heat to the upper air. The cold upper air warms rapidly due to the latent heat released during the condensation. As the cold air transforms into warmer air, the upper air pressure rises, producing an area of high pressure. The high pressure makes the air move upward away from the region of developing thunderstorms. This causes the surface pressure to drop, forming a small area of surface low pressure. The low pressure area leads to the converging of the surface air by spinning counterclockwise because of the Coriolis force. As it moves inwards, its speed increases due to the conservation of angular momentum. The wind then generates rough seas, resulting in the increasing friction on moving air. This causes the wind not only converge but also ascend near the center of the storm. Now we have a feedback mechanism. The rising air, the moisture and warmth to the upper air. Condensation for more thunderstorms and more heat. The lower surface pressure, more convergence, more rising air. The chain reaction leads to the formation of the hurricane. So what will the intensity of hurricane change if we take aerosol into consideration? Generally, the aerosol can be expected to change or redistribute the precipitation in the tropical cyclone and would also redistribute the latent heating, leading to the change of the intensity of the hurricane. Studies of Professor Daniel Rosenfield stimulate the aerosol effects by using model simulations or observations. The studies find out the aerosols could nucleate larger numbers of smaller cloud drops so that the coalescence of cloud drops could be slowed down. The aerosols present in the outer cloud of tropical cyclone could slow the rain-forming processes there. Thus, more water can ascend to freezing levels as supercooled water or ice. This process could release more latent heat that invigorates the convection of the outer clouds, drawing more ascending air at the periphery of the storm. This process could decrease the low-level airflow towards the eyeball. As for the inner cloud bands and eyewall clouds, the strong nucleation and precipitation could promote warm rain there, which reduced the suppression effect resulting from any remaining pollution aerosols that were not washed down, so that little aerosol-induced invigoration can occur there. So let's mainly focus on the peripheral clouds. The convection in the outer cloud band that weakened the convergence towards the center would lower maximum wind speed according to the angular momentum conservation. On the other hand, the intensified supercooled water or ice melts and evaporates at lower levels, thereby cooling the air that converges into the center of the storm. The cooler air has lower air pressure so that the converging of the surface air could be weakened. Furthermore, the cooler air has less buoyancy and hence dampens the rising air in the ice wall. thereby weaken the energy of the tropical cyclones. From the analysis above, we can find out that strengthening of the winds would reduce the sensitivity of the tropical cyclones. Therefore, the aerosol effect could be most effective in the peripheral clouds of the hurricane, where the wind speed would be much slower. I think this topic could let us make further progress in understanding the predicting hurricanes, and further studies are needed to learn more about the aerosol effect on the intensity of hurricane.